All right, so we're just gonna work through a couple more examples here of different shapes that we can stack. So let's make a new region, and let's define this region to be defined by a graph of y equals, let's do, I don't know, x plus 2, y equals 0, x equals 0, and x equals 3. So again, make sure we have an enclosed region, and we do. We have this lovely trapezoid. I hope you would not use calculus to find the area of this trapezoid. And on this region, we are going to stack shapes. So we have practiced stacking squares, we have practiced stacking semicircles, and in fact, we can stack anything that we know how to find the area of one of the cross section. So let's stack some equilateral triangles perpendicular to the x-axis. So what that means is that my triangles are going to sit in here on this region with the base of one of the triangles on this region. Hi. So they're going to come out like this. And they're going to obviously get bigger, and they're actually sticking up towards you, getting stacked this way. So we can see that these triangles are getting stacked in the x direction. And so my volume is going to be in the x direction. My x values go from 0 to 3. And we know that the area of the triangle is 1/2 base times height. Well, we know that the base of my triangle lies in this region. So it's just the distance from x plus 2 to 0. So here's x plus 2. This is my base. But the tricky part here is to find the height. And I happen to know that given an equilateral triangle, I can always drop down an altitude here. And whatever this distance is the same, and this distance is the same. So when I drop down that altitude, it now cuts this in half. So this is x over 2. This is x over 2. What I'm really looking for is the height of this triangle. Well, I can see that this is looking at this little triangle here. If my base is x over 2, and this is double this, I happen to have a 1, 2, rad 3 triangle. So my height is half the base times rad 3. And that's always true inside of an equilateral triangle. So my height is going to be rad 3 over 2 times the base, which is x plus 2. Again, if you want to simplify this, which I'm sure your book will do, my volume goes from 0 to 3. I have rad 3 over 4 are my constants, x plus 2 times x plus 2 dx. And lastly, because I have this little tiny bit of room down here, let's say that we want to stack, we'll stack some rectangles of height 4. So the base is going to lie in this region, but no matter what, my rectangles are going to stick out a height of 4. So they're going to look like this. So my base is growing, but all my heights are the same. And again, you can see that my rectangles are getting stacked in the x direction. So all I need to find is the cross section of one of these. So my volume is, well, again, they're getting stacked in the x direction. My x values go from 0 to 3. Rectangles, the area is base, which is just this distance right here, which is x plus 2, times my height, which is always 4. So again, anything I can find the area of one of the cross sections, I can just add infinitely many, infinitely skinny cross sections. All right, so you're going to have some in your book to try on your own.